Okay, so in grade 12, there's more, okay? So grade 11 trigonometry is building up the basic foundation, okay? So you can, some of the thing you learn here, you'll learn again, okay? Review again in grade 12. And then new things will be added on. So let's quickly just go over what's inside this topic. Okay, so first part is talks about angles, okay, angles in standard position. And we have some names about angles that we need to cover what it means, like the reference angle, what's a principal angle, what's a coterminal angle. And then in part B, we will cover right, page 3. Okay, take a look at page 3. We have 3 trig ratio, SOHCAHTOA. Okay, a lot of you have already learned that in grade 10, SOHCAHTOA. Okay. And then after that, right, part C is talking about what if the angles they are placed in standard position, okay? So that's I think that will be a new thing. Okay, and then I hope to cover to at least page 4, okay, today, because a lot of things are pretty easy. If I can, if we could, we can cover page 5, okay, but probably not, depending on the time. So let's start with page 1 now. All right. Okay, you guys keep sending things on chat. Okay, let's focus on this content now. Okay, so page 1. Can I have Colin? Okay, can you read the part 1? Angles in standard position. If
the initial arm of an angle is on the positive x-axis,
and then
and the terminal arm of an angle is in any of the 4 quadrants,
yeah,
then the angle theta between the 2 arms is said to be in standard position.
okay, thank you. We can stop there. Okay, so let's go over a couple names here. Initial arm and terminal arm. Okay, when you have an angle, right? This is an angle. You see the two blue line, right? What's in between? We call that theta. Okay, so the 2 lines that creates this angle, that's called the arms. One of them is initial, one is the terminal. Initial is always fixed. Okay, so over here you can highlight that. Initial means beginning, right? It's the beginning of the angle. It's fixed on the positive x-axis. So you have x and y axis. Positive, you see the red line now, right? This is the positive side of the x-axis. So we always fix the beginning of the angle on the right side. Okay, this is the initial. And then you start turning. Okay, so let's say over here we turned in this direction. You see the green arrow, right? So the terminal arm means the stopping place. Terminal, right? Finishing. So the stopping place, you can stop it in any 4 quadrants. So you have quadrant 1, quadrant 2, quadrant 3, quadrant 4, right? So the stopping arm is called the terminal arm. Any questions so far? So angles, remember it's made up of 2 arms, but initial is always fixed. It's not moving, only the terminal arm moves. So if we are placing the angle this way, then we call that a standard position, right? So the reason why we need to have a standard position is if I ask any one of you to draw, let's say, angle 200 degree, then all of your picture will look the same, okay? Because 200 degree, if we don't have a standard position, some people will draw like this, 200 degree, right? And then someone will draw upside down. All of them are 200 degree, right? But then they are rotated, right? It's not standard. Then it will be difficult for us to communicate, okay? So we need to have a standard way so everyone has the same picture, okay? So when everybody draw the 200 degree, it all look the same. Now for turning the terminal arm, there are two directions. If you turn the green way, right, the arrow this way, this is the positive way. If you turn the other way, okay, I'll draw with the blue. Oh, it's not showing blue. Okay, blue, right? It turns blue, then that's the negative. Okay, so positive is the counterclockwise. Okay, so look at the picture on the right side, right? Counterclockwise rotation give you a positive angle. So this one's positive. Okay, so for example, this angle could be the 200 degree, right? All the way, right? If you forgot, right? Up to here, I'll go slowly. Here is 90 degree, right? Another 90 will be 180. Half a circle is 180, and then 20 more. Okay, so that would be 200 degree. If you turn the other way, I use the blue, right? Clockwise will be negative. So going this way. So if the other way is 200, then the other way, right? If the green one is 200, the other part, the leftover should be 160. Because a complete circle is 360, okay? But because you go clockwise, you have to write negative, okay? So the angle should be negative 160 degree. So now the angle could have positive, could be negative, depending on the direction you turn, okay? But they all start at the same place, okay? The initial arm is all the same. Okay, can you raise your hand if you don't have any questions so far? Okay, pretty straightforward, right? Just knowing there could be positive or negative angle. Okay, Colin, any questions?
No.
Okay, so I'll let you try question 1, okay? These are pretty easy to go over. Find out the missing angle, okay, the data. Some of them are positive answer, some of them are negative, right? So when you have found out the answer, you can raise your hand, okay? You can use calculator. Okay, let's check the first one, okay? You guys should have at least finished A by now. Okay, Aaron, do you have answer for A?
Wait, can you just like check by like subtracting by 360 degrees?
Yep.
So wouldn't it be 290?
290, yes, very good. Right, a complete circle is 360, right? So it's less than 360 by 70 degree. So 290 degree, and then going this way is counterclockwise, right? So it'll be positive. Okay, so the number that they give you is talking about the angle in between, right? But you are interested in the curved line, how much it turned. Okay, so you're interested in going from initial, right? Always from initial, turn to the terminal arm. Have you finished all four? Okay, Nathan, do you have answer for B?
For B, is it negative 335 degrees?
Very good. Negative 335 degree, right? You are going the clockwise, so it'll be negative. So you can, so this is, what you can do is you can think about, okay, I will turn full circle first, right? 360, but then that's too much, and I'll back up, okay? So this is 360, and then take away 25, but it has to be negative. Okay, this is the way I would do it. Of course, there are other ways, right? You could also go slowly, right? Go 90, another 90, another 90, and then try to find out what's left, right? So that one will be what, 65, right? So 90, 90, 65, you can add it one by one, okay? So up to you. Question C and D, it just makes more than one turn. Okay, raise your hand if you finish all four. Okay, Yosher, do you have answer for C?
630.
630. Okay, so we can do, this is positive. So 360, add another 180, that will be 540. 540, add a 90, so 630, right? This one you can keep on adding. That's one way, right? Or you can make another way you can think of it is you do one circle 360, another circle, so 720, and then go back, right? 720 take away 90. So either way, right? All right, Brennan, can you tell us your answer for D?
580.
580, that's it?
Oh, negative 5. No, negative 5.
Negative 580. Okay, so negative 360, negative 540, and then more negative. Yeah, okay. All good. Any questions? So pretty easy, right? Just remember there are two directions to turn, okay? And remember initial arm is always on the positive X axis. Okay, next part is terminology. Terminology means the terms, right? Some of the names of the angles. So the first name we're gonna go over is called the coterminal angle, okay? And then we'll be talking about reference angle at the bottom and principal angle, okay? So coterminal angle means if I give you two angles, if they co means share, right? Together, share together. So if I have two angles, they share together the same terminal arm. Means they stop at the same place. Okay, so over here, they share the same terminal arms. Then they are called coterminal to each other. Then they are called coterminal angles. So in other words, right, so an example over here. First one is angle B, right, over there, right, the red one, beginning one, the first one. If I want to make another angle also stop at the same place, I need to turn, I use the green, okay, I need to make a full turn. So a full turn is a 360 degree. I need to add 360 degree. Okay, so if they are always 360 degree apart, right? Or if I want, I can add another circle. That's another 360, right? So all of them are coterminal. You could also go the other way, right? Minus 360, it will go back to the same place. So let me erase that, right? So I could go, B is the first one, and then minus 360. Okay, so for example then, okay, easier to understand with a number. So let's say angle B is 30 degree. Then the coterminal arm, right, you can do 30 plus 360, then 390. Okay, then we'll say 390 and 30 degree, they are coterminal angles. Okay, or I could do 30 degree minus 360. That is negative 330, right? So all these three, 1, 2, 3, they are all coterminal because they all look the same. When you draw the terminal arm, they are all at the same place. Okay, think about the clock, right? So at different, if it's 1 o'clock, no matter in the morning or midnight, right? Noontime or midnight, it look the same, right? Unless you have the 24-hour clock. All right, so over here, let's try an example. So question A, it wants us to find one positive and one negative coterminal angle closest to 0. This is the key word, okay? When you are doing your homework, make sure they don't mention that, but make sure you add this in, okay? Closest to 0 degree. So which means because you can keep on adding 360, right? So you can get infinitely large or keep on subtracting. So we only want the one that's closest to 0. So for example, 215, okay? Let us, first one, let's draw it out, okay? You don't have to draw, okay? But this one is pretty easy, right? When numbers gets big, it's difficult to draw. Right, 215 will be in third quadrant, right? More than 180. So if I want to get a coterminal angle, you can either add or subtract 360. If I subtract 360, it will become negative, right? So let's do that. So this will give you what? 145 negative. So this is called a negative coterminal angle. Okay, and then 215, if I add 360, this one will be 575. Then this is the positive coterminal angle. And those are the one that's closest to 0 degree, okay? Not including the 215, okay? Because 215 is the question. So this is what you need to do, okay? Any questions? Find one angle that's negative, one angle that's positive, and using either you add 360 or subtract 360. Sometimes you need to turn more than once, okay, to get to close to 0 degree. All right, so I'll let you try question B and C, or if you have any questions, you can ask me, okay? So please raise your hand when you finished. You can use your calculator. Does anyone have questions about how to get the positive and negative coterminal angles? Okay, Sarah, can I have your positive angle for 900 degree?
180.
Say that one more time.
180.
180, okay. So this one, if I want to get to 180, I need to subtract 360 and probably subtract one more time, right? Because it's not close to 0 yet. Okay, so subtract 720, that will give you 180, yeah. And then from 180, if I want to get to negative, right, from 900, I want to get to negative, I need to subtract even more, okay? So I will need to subtract 3 turns. So 3 times 360. Okay, this one will give you negative 180 degree. Okay, Aaron, how about C? What's your positive coterminal angle?
140.
140 degree. Okay, let me write it down. 140 degree. And what about the negative?
Negative 220 degrees.
Negative 220 degree. Okay, Colin, do you have the same?
Yes.
Okay, so let me just double check. Okay, negative 2020 degree. To get to positive, I need to keep on adding, right? 360, maybe I think, yeah, five turns, 4 turns. Yeah, okay. So okay, you do 4 turns, then I'll give you the positive, and then the other one, you need to add 1 less. Okay, never mind. This one should be 5. Right, and then the other one is 4. Okay, I'll give you negative 220. Any questions about these two? So if you look at the homework, okay, we're not done yet, okay? I'm just saying in the homework what it will look like. So like over here, question 2. Determine the smallest, smallest means closest, right? Closest to 0, smallest positive, and greatest negative. Greatest negative means also closest to 0, right? Because when it's negative value, if it's closer to 0, then the bigger it is, right? So that's why it worded differently by saying the same thing. So find two angles. One is positive, one is negative, coterminal angle to each of the following. Okay, so that's the kind of question you will get. All right, so that's the coterminal part. Next part is, I want to go to reference angle now, okay? So reference angle is an angle that will be using later, okay, for finding other things. That's why I call it a reference, right? It's a tool. So reference angle is defined as this. It's an angle between 0 to 90 degree. And you see it could be 0, could be 90, right? There's an equal sign. That is formed between the terminal arm and x-axis. Okay, it did not say positive x-axis or negative x-axis, just the whole x-axis. So what that means is if I draw a picture, okay, let me draw a picture here. This one is the x-axis, right? The red one is the x-axis. The terminal arm, if it's in the first quadrant, the green line, okay, terminal arm, then the reference angle will be this green dot. Okay, because it's in between the terminal arm and the x-axis. And it has to be less than 90, right? Less than or equal, so it cannot be the other one. The other one is too big, okay? So that's why it will be there. Now, if the angle goes to the second quadrant, then the terminal arm and the x-axis will be here. So that's the reference angle, okay? Third quadrant, this is the reference angle. Fourth quadrant, the green dot is the reference angle. Okay, so all the smaller angles they are the reference angle. So it looks like a bow tie, right? Or butterfly. Butterfly. Okay, so remember this picture. That's what reference angle means. We'll try an example, okay, so you understand better. So here we want to find the reference angle. So for 500 degree, of course, we need to know where it stops. So can you guys try to draw 500 degree, just approximately? All you need to tell me is which quadrant it stops in, okay? So once you finish drawing 500 degree, please raise your hand. So Brandon, which quadrant does the terminal arm stop?
Fourth one.
Fourth one? Okay, let's try it. Colin, how about you? Where is the terminal arm? Which quadrant?
I got the second one.
Second one? Okay, let's see which one, okay? This one is positive 500, right? So we need to make sure you turn in the positive direction. So that will be 90, 180, 270, 360, right? If I want to get to 500, I need to turn 140 more. So 140 more, it should be in here. Okay, so first you got to figure out where your angle stops in. okay? You turn 360, right? 360, but not there yet. You need to add 140 more, okay? You can use.
Actually, that's what I meant. I just forgot which quadrants is where.
Okay, so this is 1, 2, 3. Yeah, you go in counterclockwise, okay? They order the quadrant according to positive angle, right? Because you always start from positive x-axis and then turn counterclockwise. That's why they call it 1, 2, 3, 4 like that, okay, in that direction. So if that's the case, the reference angle should be here, right? Quadrant 2, right? According to our butterfly. So how big is the reference angle now? Okay, you guys can write it down. Okay, when you have an answer, please raise your hand. So look at the picture. How big is the green dot? Anyone has trouble finding a green dot? You can raise your hand. No, not raise your hand. You can ask me. But if you finish, you can raise your hand. Okay, Nathan, what's the reference angle?
I got 40 degrees.
40 degrees. Yep, 40 degrees correct. Anyone has question about how to get 40 degree? Or why it's 40 degree, you can ask me.
Yeah, why is it 40 degrees?
Okay. Aaron, do you know where the reference angle is?
Yeah.
Okay. You understand why we put the green dot there, right? Yeah?
Yeah.
Okay. So the reference angle that we want to find is the size here. Okay. So if I want to figure that out, I need to see how much I've turned already, right? So let me erase the red circle first. So I need to go 360, right? You understand? You caught up so far? 360 there?
Yeah.
Okay. How much more do I need to turn so I can reach to the terminal arm?
140.
Yes, okay. So the blue line, I'm gonna use the blue part. The extra part, this is 140. So it needs 40 more to make a half a circle, right? Because like if this part is 140, then this part is 40. Because a straight line, right, half a circle is 180 degree. Does that make sense?
Yeah.
Okay, so that's why it's 40 degree. Do you get it now?
Yeah.
Okay, we are looking for the little slice that's between the terminal arm and the x-axis. We call that the reference angle. Okay, so any other questions? Why it's 40 degree? Okay, so I would like you guys to do question B and C, okay, by yourself, just the reference angle now. So start by drawing the picture, and then you can put a dot on the reference angle and write down the value, okay? All the reference angle has to be positive, okay? Because all we care is how big the size is. We don't care about directions when we talk about reference angle. But when you are drawing, you need to draw according to positive or negative sign, okay? So first draw the picture and then figure out the value of the reference. Okay, when you have finished B and C, you can raise your hand. Okay, can I check answer for B first? Yosher, can you tell us which quadrant is angle B?
3.
Yep, very good. Okay, so 180 and a little bit more, right? Quadrant 3. So our reference angle will be this part, right? The green dot. So how big is that? Brennan?
I don't know. I'm stuck on that.
Okay, you know how I get the red part, the drawing part?
Yeah, I got that part.
Okay, how about the green dot?
No clue.
The green dot is the reference angle. It has to be in between the terminal arm and x-axis, right?
Mm-hmm.
You see the 4 green dots up there?
Yeah.
Yeah. So if it's in quadrant 3, the green dot has to be drawn there. Okay?
Okay.
Okay, so the green dot represents the location of the reference angle. So now we are interested in finding how big this little slice is. Okay?
Jason.
Okay, Brandon?
Jason.
Yeah. Nathan?
Is it 20 degrees?
Yeah, it's 20 degree. Yeah. Okay, so let me go over it. Okay, so so Brandon,
Yeah,
right? So how big is this shaded part? How many degree?
that's 180.
Yeah. So how much more so we can get to 200?
Oh, 20. Yeah, okay.
Yeah. Okay, so we are just looking for the slice, a part of the whole turn. Okay.
Mm-hmm.
So let's try another one. All right, question C. If you guys finish question C, you can raise your hand. Remember, this time is turning in the negative direction, okay? Okay, so can I ask Colin, can you tell us which quadrant is negative 900?
It's on the x-axis.
Oh, on the x-axis. Which side? Left side or right side?
The left side.
Left side? Okay, let's take a look. Okay, so negative 360, negative 720, and then negative 180. Yeah, okay, so I'll be stopping there. Okay, so if that's right on the x-axis, what do you think the reference angle is then? Yosher?
Is it 0?
Yes, then this one will be 0, right? Because reference angle has to be in between x-axis and terminal arm, but it's right on top of it, right? So there's no space in between. So this is 0 degree. If you get something like it stop on y-axis, then what do you think the reference angle is then?
90.
Yeah, it will be 90, okay? If it's on the y-axis. It doesn't matter at the top or bottom, okay? If it's at the top, it's 90, right? 90. If it's at the bottom, it's also 90, okay? Reference angle the same. Okay, last thing, okay? Last thing is pretty easy. Let's finish that today, okay? Principal angle is the first positive angle in certain position. So because you already got a picture, okay, so all you need to do now is to find the first positive angle to reach this, the arm. So for example here, let me use the, I'll use blue then, okay? So the blue line, which I already have it here, okay? The 140, right? You see the 140, the very thick blue line. This one is positive. It's the first positive that can touch the arm, touch the terminal arm. So we call that the principal, the main one, okay? 140 degree. Because if I keep on turning, I can get the second one, but I want the first one, right? So for the question B, the first positive that I can get, it will be the picture like this, the blue one. The first time positive and touch the arm. Okay? You always start from the initial. For question C, start from the initial, right? The first time it touches the arm, right? That's called the principal. Right, so please find the value for principal angle for B and C, and you can raise your hand. Okay, Colin, what's your principal angle for B?
200.
Yep, 200. Okay, so you could also get the same thing as the question, right? As long as it you follow the definition. Okay, Brandon, you want to try C?
No.
Do you understand how I draw the blue lines?
Yeah.
Okay, principal angle is starting from the initial and then you turn. When do you stop?
It's a 180.
Yes. Yeah, okay. You just stop until it hits the arm. You don't care about, so it's always less than 360, right? Because you have an arm either in one of the 4 quadrants, right? The first time it hits the arm, then you call that the principal angle. Okay? So if anyone has questions about anything we covered today, please stay after class. Otherwise, I'll see you next week. Okay? So have a great weekend, guys. Bye-bye.
Bye.
Bye.
Bye-bye.